Sure. So good afternoon, everyone, and welcome to this week's edition of the NITheCS Micro School. Today's presenter is a return presenter, Shane McFarthing, from recently doing a micro school on GitHub Actions and a mini school also a few months ago. I'm the host of the micro schools. My name is Dean Brand. I'm a PhD student working with Prof. Pietrocioni, who's the director of NITheCS, and Shane is also working on his PhD with Prof. Pietrocioni. He is working also with Prof. Ilya. His research is focused on the development of quantum algorithms for applications suited to noisy intermediate scale quantum devices. He's also completed a Bachelor of Science and a Master of Science in Computer Science at UKZN, where he explored variational quantum classifiers. So definitely the expert to be teaching us today about the topic of Pytest, a testing framework in Python. And yeah, I think that's long enough introduction. I'm looking forward to seeing what you have to say about it. I'm looking forward to learning about Pytest. So take it away, Shane.
Thanks, Dean, for that very great introduction. Okay, so let me just share my screen quickly. Cool. So can you see?
Yes, we can see. Thank you.
Awesome. Yeah. So as Dean mentioned, today's micro school is going to be on testing with Pytest. I'm sure you probably read the abstract, but essentially the purpose of this micro school is to give you a short introduction into how Pytest might be useful in your day-to-day development in Python. So to begin with, we can talk about why even perform testing in the first place, or why have unit testing. Well, the purpose is to catch bugs early on, essentially, to make your development as efficient as possible. So you might be working on different functionalities, different features, making changes. And in the last micro school, we discussed how GitHub Actions can allow you to use Git easily, so you have version control. And testing is another important aspect of that, because it allows you to make sure that your code is working and that if you change something that causes some sort of bug or error, it gets picked up immediately. It doesn't get propagated throughout the code and then rear its head later on and be a bit of an ugly surprise. So it can also help you to collaborate with other people, because then if you're working on the same code, there's very clear expectations about what needs to happen, how the code needs to work, what the behavior is. So it's just a very good practice to implement some tests for your code. And if you're working in Python, Pytest is a really useful tool for this. So it's a Python-based testing framework, and it's extremely easy to use. It uses simple assert statements, but it can be configured to provide a lot of different functionalities. And in general, tests that we write using Pytest follow the same sort of framework. So we can look at it as arrange, act, assert, and cleanup. So what we try to do with a test is test some functionality, or like a function or something like that. And then we want to make sure that the behavior is as expected. So typically we'll have some sort of expected output, and then we'll compare the output of that function with what we expected. And the test passes if it matches and it fails otherwise. So in arrange, the first step, what we're doing is we're getting everything ready for the test. We're maybe preparing the data that the function needs to use. We're just setting everything up.
Sorry, Shane. Sorry to disturb. I see you clicking around. Are you changing slides?
So
because
no,
on the same
my
slide.
mouse. Every time I bump my mouse, the
Okay.
highlights
No,
have moved.
sorry.
So
I
I'm still
thought
on
you
the
were
same
clicking
slide.
on. Okay. Perfect. Sorry.
No worries. It would have been a disaster otherwise. Great. So yeah, so in arrange, what we're doing is we're preparing all of the things that are needed for the test. And then in act, we actually we trigger the behavior. So we call the function. And then in assert, what we want to do is we want to make sure that the outcome of the test is as we expected. And then lastly, we do the cleanup. So sometimes there might be certain things that need to be changed so that we don't affect the environment for other tests, and you do that in the last step. So in this micro school, we'll go through some of the like core functionalities of Pytest that you might find very useful. So just to start off with, we can look at how you would even write a simple test function. So Pytest is nice because it will automatically detect your tests in the directory that you run the command or any subdirectories. And we just have to name the files that contain our tests to start with test underscore or to end with test underscore before the Python extension. And then Pytest will automatically detect those files. And then within those files, the test functions that we write need to, the names need to start with test so that it can be detected. And then within the functions that we define, we're going to use plain assertions. So like typical Python assertions, but they have some slightly more advanced introspection. So we get a little bit more information about the asserts if they fail. So an example of a very simple unit test for an addition function is that first we define the function. So it's add, which takes two operands and returns the addition of them. And then we have our test function, which is the name starts with test. And this is a test add function. What we do is we assert that the return value of add with the two operands 2 and 3 is equal to 5. So that one should pass. So in my case, I put this code simply in a file called simple test. So that also obeyed the naming convention. And then you just invoke Pytest by saying Pytest, and then you can give the path to the test file. Or you can also just call Pytest and it would automatically detect the test file in this case and run the tests. So you can see here, the test session starts. It describes the platform that the tests are running on, what the root directory is, and then it can see it collected one item. There's one test, one test file there, and then there's a dot, meaning that there's one test function that was run and it passed. And we can see it explains in our summary for us at the bottom, one test passed in 0 seconds because it was negligible time. So that's just an example of how to do a very simple test function. And then we'll just kind of develop this over the course of this micro school. So kind of gave a brief description of how the tests are detected by Pytest. So like I said, it automatically detects tests within files that are named within the convention. And then we can use substrings to specify which test functions we actually want to run. So that's another kind of control that we have. So if we look at the example on the left here, where we have two functions, add and subtract. Here we define two test functions for them, one for the add function and one for subtract. They both start with test. And in this case, we say that we want to check that the numbers 2 and 3 added together are 5, and the numbers 2 and 3 subtracted give you -1 in that order. And now that's our test file. It has these two test functions in it. What we can do using the -k flag and a substring is we can specify to only run test functions that have the substring add in the name. So we can see in this file that would only be this one. So if we run the command pytest -k with the substring add and the same file path, it collected two items, so it saw that there were two test functions. It deselected one of them, so that would be this subtract one because it sees that it doesn't match the substring. Then it selected the one that did match the substring, which in this case was add, and then it runs that test. And we can see in the summary it said one test was passed and one was deselected, in that case because it didn't match the substring. So we can see like it doesn't necessarily have to be you run everything in the test file. We do have some control to specify exactly which tests we want to be running. And that's useful because sometimes when you're developing features, you know that something that you changed, it might only concern certain parts of the code, and all of the tests, the other tests that are unrelated might be quite slow to run. So you can skip those, just run specific tests using something like this. Another thing that you could do is you could group the tests. So we can group them easily using this decorator at pytest.mark and then the group name. And we can specify our own group names. And then if we give the label, the decorator for that group to a certain number of test functions, it becomes very easy for us to run only those tests, the ones that are within the group. And we can isolate that using the pytest-m flag and then the group name. So if we want to specify our own groups, we also have to provide that declaration inside the pytest.ini file. So an example of that would be here. We're going to use a marker called example. So in the file, you'll have your pytest markers, and you add the marker you want. In this case, it's example. And we have a short explanation of what it is. So that's mark tests as part of the example group. How you would use that would be over here. We've added that decorator on top of the test add function. and then also the test subtract function. And I've just added another function here, for example, that doesn't use that group. So now if we look at our test file, it has 3 tests in it, and 2 of them belong to the same group and the other one has no group. So when I run the Pytest command with the -m flag, and I say I want to run the example group, you can see that 3 tests were detected. 1 was deselected because it didn't belong to that group. 2 were selected because they did belong to the group. You can see there's 2 green dots there. That means that both tests passed, and then we get the nice summary at the bottom saying that 2 tests passed, 1 was deselected. So we can, if you were like looking for a certain function, you didn't remember the name and you only wanted that one to run, you could use something like what we showed on the previous slide, where you search for a substring for the test function names. Whereas if you were trying to systematically group tests based on like related behaviors and things like that, you would try to use this test grouping with your Pytest decorators. So then that brings us to another useful functionality in Pytest, which is fixtures. We mentioned how when we do testing, we're trying to make sure that the behavior of the different parts of our code is as expected. And very often that means you need some sort of input data. We mentioned the arrange, act, assert, and cleanup kind of framework. And fixtures are very useful for the arrange component. So when we're setting everything up for the test. So fixtures are functions that handle reusable setup or test data. They're very useful for reducing code duplication and having very easy setup of input data, which can sometimes be a bit complex. And they are specified using the pytest.fixture decorator. So if we look at this example, we have a fixture function called input value, and it creates a value input, which in this case is set to 39, and it returns that. Now, once you've specified this fixture function, it will be used automatically in any test function where you provide that function, that fixture name as an argument. So if we look at these 2 test functions, we put input value there. That's the name of this fixture function. And when the tests are detected, it will see that this is provided as an input, and it will automatically evaluate this function. So it will be as if you wrote 39. So in this case, we're going to run this test that the input value is divisible by 3, which should pass. And then we're going to run this test where we check if it's divisible by 6, which we know should fail. So if we run the tests again using this fixture function, we can see that it found 2 tests. The first one passed with a dot as we expected, and the second one failed. And then it gives you a description of the failure. And it says that the input value was set to 39. And then at the assert, it was asserting that 39 is divisible by 6, or 39 is divisible by 6 with no remainder. And then it failed with an assertion error. So this gives you an example of what it looks like when a test fails. And earlier I mentioned that the assertions with Pytest have slightly more advanced introspection. So you can see that here where it actually gives you the value of what input value was at that point, instead of just saying assert failure input value divisible by 6. So fixtures will very often be used like if you write complicated functions that require some complicated setup of input data, maybe using different classes and things like that, fixtures will become really useful for you. And you can use as many fixtures as you want. So you can have a base fixture that then calls that's used in another fixture function, that's used in another fixture function, which is then used in a test function. And what happens is if there's a failure in one of the fixtures, the test won't run at all. It will then Pytest error, but the error won't show that the test failed. It just would have failed before that point. Another thing that's important to consider is the scope of the fixtures. So when we define fixtures in test files, they have scope only within that file. But if we define them in a conf test .py file, which is in like the root directory of your project, then that fixture will become available to all test files. So to just show you the difference, imagine we have this file test_math.py, and we have a fixture here called the input value, which we used in our previous example. This fixture will only be available to functions that are defined within testmath.py. But if we were to define the fixture instead in the conftest.py file, then this fixture could be used in any other test file by any other test function. So this is a bit of a consideration for the scope of the fixtures. Now, fixtures are one way to try to give a reusable setup for your test functions, and another way to quickly test, well, not quickly, but to remove code duplication. If you want to write tests for one single function, but with multiple different inputs, you can use parameterize tests. So Pytest makes this quite easy. All you have to do is use the decorator pytest.mark.parameterize above your test function, so like we do here, and then it will allow you to avoid unnecessary code duplication, and it will run the test for all the different parameters that you specify. So in this case, we have a test function called test multiplication by 11. It takes a number and an output, and what it tries to do is it makes sure that when you multiply the first argument num by 11, it's equal to the second argument, which is output. So we can test it with a bunch of different inputs by using the parameterize decorator. The first thing to do is to specify the order of the argument. So we're going to say that the first, okay, I guess one thing to specify is that the first arguments within the parameterize decorator is like a description of how the arguments are ordered when passed to the function. And the second one is a list of tuples. So each tuple represents a separate test case, and then this string breaks down how they're ordered within the tuple. So we'll say the first element of the tuple is num, and the second element is output. So in this case, the first one, we'll have num is 1 and output is 11. So we'll check that 11 times 1 is 11. That's true, so it will pass. The second one is 2 and 22. So it'll be 11 times 2 is equal to 22. That's true. And then the last one is 3 and 35. So we'll say 11 times 3 is equal to 35. This assertion will fail, and then that will show that this test should fail for that case. So rather than having to write 3 different functions, or 3 different fixtures, all providing different inputs, you can make it a lot simpler using this parameterize decorator. So if we look at the output of this test, once again, we just run the test with Pytest tests simple test, which is where I happen to have it. So you collected 3 items, even though there's only one test function. It saw this as 3 separate tests because of the parameterize decorator. It says that the first test passed, the second test passed, and the third test failed, which we expected because of we know that 3 times 11 is not equal to 35. You can see here, it explains where it fails. It tries to assert that 11 times 3 is equal to 35, which is obviously false. And then it gives you your nice little report at the end. So parameterized tests are a really easy way to try to reduce clutter in your testing and just account for a lot of different test cases. Now, something else that's useful in Pytest is the concept of skipping tests and also tests that are expected to fail. So sometimes with certain tests, we don't want to run them. We know, like, we just want to skip them for now, or perhaps we know that a certain test will fail because we're still busy implementing that feature. In that case, or in those cases, we can mark the test either to be skipped or as an expected failure using these 2 different decorators, pytest.mark.skip or pytest.mark.xfail. And what they do is they change the way that Pytest reports on the results of those tests. For example, if we take a look at this first test function, which we've marked as xfail, the reason we've marked it as a test function that's expected to fail is because the argument of num equals 100 is asserted to be more than 100, which we know is false. The next test, which is greater than, it says that num equals 100 is greater than or equal to 100. And we know that this is actually true, but we'll just show you what happens if a test that's marked with xfail actually passes. We'll discuss that in a moment. And then the last one, we just mark a test to be skipped. So this test, which would pass, sorry, there should be a num here. It should be num less than 200. when we run this this test file, you see it picks up 3 tests, and then we get a slightly different output here. It says the first one failed. That's what it says. 1 test X failed. That would be this one, because it did actually fail, but we marked that as expected. The second test passed, but because we marked it as X failed, the status is X passed, and then the third test is skipped. So that's why I went small x, big X, lowercase s. So if you have tests that are marked with skip or X fail, there is a brief summary on them, but not the same as you would have gotten, for example, here, when normally when a test fails, you get all this big detailed output. We can kind of skip that if we're not too worried about it. Something else that's useful is the ability to specify when test execution should stop. So sometimes we know that, let's say we have a really big test suite, spend a lot of time developing our code base, we have a lot of unit tests to run. Some of them can actually take quite a bit of time to run. And when we make a change, perhaps we don't want to accept any failures at all. And at that point, if one test fails, there's no point in sitting around and waiting for every other test to run and wasting your time when you don't even want that to happen. So what Pytest allows you to do is to set like a failure limit. So after a certain number of failed tests, the test execution will stop. So, and we can specify this using the command line flag -- max fail, and we specify the number of failures. So here, if we have these tests, the square root failure, we're trying to check that the square root of 25 is 6, that 7 squared is 40, and that 10 is equal to 11. So all 3 of these tests should fail. If we run this test file with the max fail set to 1, then what we would expect is after 1 test failing, it will cease execution of the test suite. So we take a look at what happened. It collected 3 tests and 1 test failed. You can see here there's no other dots or letters or anything, meaning that only 1 test was executed. And we can see the description here. It got to test square root failure, which is this first test function, and it failed where it tries to assert that 5 is equal to 6. So obviously there's an assertion error, and then it says it failed this test, stopping after 1 failure, and then it gives a report only on the 1 test. So it's very useful. You can configure kind of how strict your testing is and how long you will allow the testing suite to run for. Talking about trying to save time when you're testing, another big thing is that perhaps as your test suite grows, it becomes quite time consuming to run all of the tests. And Pytest by default will run your tests sequentially. It's possible to also run your tests in a parallelized manner. You can use the plugin Pytest -xdist, which you can install with pip, to then run parallelized testing. After you've installed this this plugin, the way that you can run parallelized tests is if you provide the -n flag when you run it, and then this is the number of cores that you want to use. So for example, if we have our simple test suite again on the left, where we have 3 test functions, 1 for add, 1 for subtract, and 1 for using both of them, then when we run the normal sequential case, we have Pytest with no flags. It runs 3 tests, passes all of them in 0.1 seconds. When we do the parallel testing, you can see it says that in this case, I used auto as the number of cores. So you could specify up to the number of cores that your device or system has. If you specify auto, it will automatically set it to the maximum number. So for me, it set it to 8 workers. It says 3 tests passed and then in 0.4 seconds. So if you notice that when you do sequential testing versus parallel testing, it took longer for the parallel part. That's because there is some initialization overhead for the workers. And in a situation like this, that overhead is quite substantial compared to the actual runtime. But as your test suite grows, this would become like negligible because the initialization is very, very low. And then you would actually get a benefit out of doing parallel testing. And then, yeah, just to kind of close off today, I'm just going to show you how you can integrate these tests with your GitHub Actions, which I discussed in the previous mini school. For anyone who didn't attend that one or isn't familiar with GitHub Actions, essentially, just to recall that Git is a version control tool that you can use, and GitHub is a online way for you to host your repository. So your code bases that you work on, that you can interact with other people, and it's very effective. If you at this micro school, you probably heard of GitHub. GitHub Actions are a way for you to automate certain behaviors. So one thing that you can do is you can set it so that tests will run automatically based on certain events happening. So that's why it would be very useful to write all of your unit tests, and then you can simply do certain things and those tests will run. What you have to do is define a workflow that runs the tests on specific triggers. And like all GitHub Actions, that workflow file has to go in .github/workflows. So within that directory in your repository. And then we have an example of a workflow like that on the right here. So the workflow's name is run unit tests. This workflow is triggered on pull requests, but specifically when a pull request is opened on the main branch. So let's say you were trying to, like you made a feature branch and there's like a test suite, and you've now developed your feature and you want to open a pull request to merge your changes from your feature branch onto the main branch. When you open that pull request, this workflow will get triggered. And what this workflow actually does is it will run your tests. So step by step, we can go through it. We specify the environment for the workflow to run on, which in this case is just Ubuntu. And then the steps. The first step is to check out a version of your code using an existing GitHub action. So this will get a copy of your code into the action environment, and then we'll set up Python 3.10 for us. Then you have to install the install pip and install Pytest, and at that point you can run your tests. So this would allow you to have a test suite that would run automatically on people's code when they try to merge it into the main branch. So it'd be very useful for version control, making sure that people don't introduce broken code onto your main or production version of your code. So that's just a brief overview of what you can do with Pytest. There's a lot of resources online on how you can use Pytest effectively. But in general, it's just a good way to get acquainted with writing tests. I know most of us write the code and then we just kind of always trying to move as quickly as possible, and we develop, and then sometimes bugs arise and we then have to go back, try to remember what is it that broke, when did it break, it used to work but I don't remember how it's broken now. Tests are a really good way to try to control all of that, because that way you can make sure that that everything is functioning as expected, and when something changes it gets picked up, because there's a time investment in the beginning to write the tests, but usually that will pay off over enough time iterating through the code development. Yeah, great, thank you.
Very nice, thanks, Shane. I'm sure I'm not alone in being one that uses just print line testing every time for a false version of testing, but after this, no more. It's a very useful topic for us to also learn. Yeah, so thank you again for that. I see there was one question in the chat so far just about asking about the slides. The recording of this micro school will be put onto the NITheCS YouTube channel, and I believe the slides will be linked either there or on the NITheCS website. But yeah, they should be provided quite soon. Are there any other questions from the participants?
No, I also would like to thank Shane, because I also learned lots of interesting things, and I'm in the same category as Dean. I just print out whatever goes wrong. Yeah, no, thank you very much, Shane. That was really useful. Thank you.
That's a pleasure.
Obviously, all the other participants never make a mistake in Python.
Yeah, I only started using this myself recently. Like, I think all of us can say we're used to just using print statements and saying like, I understand the code, it's fine. The problem is when either you leave too much time between reading the code and then you realize actually, you know, no one understands the code now because I've forgotten how it works, or it just becomes too complicated to track down. And that's why I said like there is a time investment, but it usually does pay off for like the more complex tasks.
Yeah. No, excellent. Thank you very much.
And I can see how this would work for if you also introducing new features in your code, but one of them unexpectedly breaks something very old just for some weird clash, but the tests will pick them up. So you'll know exactly where to find it.
Yeah, it also helps you. I find it kind of helps you to prematurely debug your code, because when you're sitting there trying to design the tests, you have to think through all of the different cases that you would expect your code to work for. And you try to find edge cases that would test your code. And sometimes when you're doing that, you realize, oh, I never accounted for that, and you can go back and fix it.
Yeah, so this makes for a smoother developer experience in general.
Exactly.
Yeah.
Excellent.
Yeah, doesn't seem like there's any more questions.
And Shane, sorry, just out of curiosity, I mean, you introduced Pytest, yeah? Are there similar programs or packages if you, for instance, code in C or in
Yeah, of course,
or whatever, yeah? Are there similar versions? Yeah.
And a lot of them, they work the same way. There's like standards for how they want it to operate.
Okay, that makes sense. Yeah, but there is not one code that tests in every language.
I'm actually not sure. Maybe, but I think I'm not sure it would be the most powerful one then.
I don't know, just okay, but it's, you know, once you know there are solutions, there are probably solutions in every programming language or something similar. Yeah. Excellent.
Yeah, I know, for an example, in Golang, they have a built-in testing into the language, into the compiler. So it also takes care of that automatically. But I guess for things like Python, and I know in JavaScript, there's a few different packages. So I guess it's just dependent on your ecosystem.
Yeah, I think so.
Yeah, see, there's a participant saying that they really enjoyed the microschool, but they've been using Pytest. It has been very helpful. So I'm glad that we getting the information into the right places.
Yeah, no, excellent. And if the moment Shane shares the slides, we will upload them on the website with the link to the video and everything. Yeah.
Great.
Excellent.
Yeah, so it doesn't seem like there's more questions now, but you can always put a comment on the YouTube video when it goes up, or reach out to anyone at NITheCS for any questions. But with that, I think, we can wrap up with this for the day and move on for the rest of Friday. Thanks again, Shane.
Good.
Thank you.
No problem. Thanks, everyone. Have a nice weekend.
And thank you, Dean, for organizing the series. Thank you very much. And thank you to the online participant. Please,
thanks everyone for
your
joining.
colleagues and friends to join us, because we try to do this very useful, or Dean tries very hard to organize a useful kind of skills series. Yeah. And please invite your friends even to watch past episodes on the YouTube channel. Thank you very much. And if you have suggestions, please don't be shy. Yeah. If you need something, tell us. And if you want to volunteer, tell us as well. Yeah. We're always looking for interesting speakers. Yeah. Sorry, Dean.
I've left my email
over your job.
Yeah, it's okay. Yeah. Thanks, everyone.
Thank you.
Thank you.
Bye. Thank you, Shane.
Bye.
Very much.
Pleasure. Bye.
And Shane, we are still waiting for your mini school, micro school on Canva.
Oh yeah, that can be another one.
That I'm waiting for. Yeah.